Okay, quadratic functions. So we learn polynomial. So we start from the easiest one is quadratic, and then we learn cubic, quartic, and a higher degree functions. So the general form for quadratic function will be ax squared plus bx plus c, and the turning point will be y equals to ax minus h squared plus k, and the intercept form will be y equals to ax minus x1 times x minus x2, where x1 and x2 is the intercept. Okay, for the turning point, h and k is the turning point. So that's three form. You must know that, and it's very helpful for doing a lot of questions. Okay, example 1. Completing the square for y equals to ax squared plus bx plus c, hence find the axis of symmetry and the turning point. So there's no numerical values, so you just use a, b, c to complete the square. So that really can practice how we should complete the square. So we cannot complete square with this a together with x squared. So I will take a as common factor. You have a times x squared plus b over ax, and I'll throw the c out. Okay, I'll throw the c out. So y will equals to a x squared plus b over ax. Okay, plus half of the middle term squared. So half of that will be b over 2a squared, and I'll subtract b over 2a squared, and then plus c. Okay, one thing I see 30% of you making mistake because today I go through your papers what you did last time, and I see a lot of you have problems in completing squares. So what's the problem is you forgot to times this a with the constant. You can see on your paper. So when you complete the square, you still have this big bracket here. Okay, this bracket hasn't like just disappeared. And for those three terms, you can complete the square. What you take is the x, the sign, and the number inside. So it's a x plus b over 2a squared. Okay, what you subtract that is b squared over 4a squared. It's still in the bracket, and this a is still the common factor. How many of you forgot to times the a back to that and directly open the bracket? And then plus c here. Then y equals to a. Open the bracket, so a times that squared minus b squared over 4a plus c. I can make the same denominator. I can say that's x minus negative b over 2a because x minus h plus k, so it's 4ac minus b squared over 4a. Okay, c can become 4ac over 4a, so it's 4ac minus b squared. Then the axis of symmetry will be x equals to minus b over 2a, and the turning point will be minus b over 2a, comma 4ac minus b squared over 4a. Okay, you can remember this formula and directly apply this formula when it's asking for turning point, or like I will prefer like we'll make the turning point form again, like completing the squares and see where's my turning point. Okay, so you can decide which way you like. You can remember the formulas, or you can remember like use completing square to find turning point. Okay, so quadratic formula. You want to solve quadratic equals to 0. Quadratic formula will be x equals to minus b plus minus square root b squared minus 4ac over 2a. I was very surprised today because I go through the last two papers you did for the first week and last week, and I find someone don't know quadratic formula. Okay, so that's a big issue. Okay, if you don't know quadratic formula, that's a really important thing you need to learn. Okay, and what is the discriminant? Discriminant is this triangle, and it's b squared minus 4ac. Okay, b squared minus 4ac. It's not b squared minus square root 4ac. Okay, I see some answer like that. You know that's not correct. So it's b squared minus 4ac is the discriminant. So for discriminant, we can see a lot of things. The first thing we can see is number of solutions. How many solutions? 0, 1, or 2. And we can know how many intercepts you can have. 0, 1, or 2. The nature of the solution. What's the nature of the solution? If b squared minus 4ac is a square number, if that's a square number, then you will have rational numbers. Okay, you will have rational numbers. If that's not a square number, so you will have the square root 13, something like that, it will be irrational numbers. Otherwise, irrational. Okay, otherwise it will be irrational numbers. Okay, number 4 is the number of intersections between the graphs. Okay, I have a quadratic and have a linear, and I want to know how many points of intersections I can have. I can have 0, 1, or 2. So I will use the discriminant to decide that. Okay, you use the discriminant to decide that. Okay, to factorize quadratic. Okay, factorize quadratic. You will factorize polynomials later, like cubic, quartic, but the basics is how we can factorize the quadratic, because quadratic is different compared to cubic. Cubic will find one linear factor first, and then we left with the quadratic, and we factorize the quadratic directly. So for quadratic, first thing you need to actually do is checking the discriminant is smaller than 0 or not. If it's still smaller than 0, it just cannot factorize for sure. It's just not worth you to try that. So you would, some students like try about 5 minutes and say, oh, I can't factorize. Okay, you should know at the very beginning, and you shouldn't pay any attention to that equation anymore. So we check discriminant first. And the second thing is, if it is in the form ax squared minus b, which means no x term. Which means no x term for that one. There's no middle term. And b is greater than 0. We can apply the formula, the Stokes formula, difference of perfect square. Okay, we can use the difference of perfect square to factorize that. So we have 2x squared minus 16. I can take a common factor 2 first and minus 8. And then we have 8. We must write 8 in the square form, so it's 2 root 2 squared. Then I have 2x plus 2 root 2 times x minus 2 root 2. Okay, this one. Have 3 minus that minus 75y squared. So I can take 3 as common factor with the square bracket, x minus y squared minus 25y squared. But 25y squared is not really satisfying the form, so that should be minus 5y whole thing squared. And that gives you 3x minus y plus 5y and x minus y minus 5y. Okay, 3x plus 4y and x minus 6y. Okay, that's for the quadratic. You have something squared minus something squared. We directly use the Dobbs method. And for some quadratic, it's really easy for me to use the cross multiplication way, like to factorize, to see it and factorize it. So for example, this one, I can have negative 8 and 1. I want to make a negative x. So I will have 1 and 1, which is the coefficient for the x squared. And negative 8 can become negative 2 and 4, or negative 4 or 2. So I need a negative 2. I may have negative 2, negative 4, and 2. So minus 4 plus 2 will give you negative 2. So I will have x minus 4 and x plus 2. Okay, that's really easy because I can see the back one factor plus together can give you the middle term. I can directly factorize in this way. Okay, the next one is negative 15 and 12, try to make it 11. So minus 15. What I will do, I will take this, I will think the minus at the front is quite annoying. So I'll take the minus out, and that will become like this. Okay, I'll factorize the things inside. So 15, it will have 3 and 5. It's very unlikely to have 1 and 15. Okay, it's very unlikely to have 1 and 15. So I'll use 3 and 5, the closer numbers. Okay, 12 can be 4 and 3. Okay, 4 and 3, or 3 and 4, negative 4, 3, 4, negative 3, or 2, negative 6, 6, negative 2, all that combinations. I want to make a negative 11. I will try 4 and 3, not putting the negative sign on yet. So I'll have a 20, I'll have a 9. 20 and 9 can give me a 11. Okay, 20 and 9 can give me 11. I need negative 20, so I need negative 11, I need negative 20, larger negative numbers. So that must be negative. So it must be a negative 4 and 3. That plus together give me minus 11, which is a tick. So it's a minus 3x minus 4, 5x plus 3. Okay, minus 3x minus 4 and 5x plus 3. Next one, if all of the three methods not like is discriminant greater than 0 and you have the x term and you can't use the cross multiplication way, you will think about completing square in the end. Okay, if the discriminant is greater than 0, the mass can be factorized. And you can't really find any easier way, then must go through the completing square step. So for example, we have a 1 coefficient and 1 coefficient, you cannot make an 8. Okay, you cannot make an 8. So I will do completing square, so it's x squared minus 8x plus half of the b squared minus half of the b squared, and you still have the constant at the back. So you have those three can be complete together, so x minus 4 squared minus 16 plus 1 is minus 15. Okay, minus 15. So minus 15 can be square root 15 and then squared it back to number 2, okay, the dots. So go back to the number 2. So it's x minus 4 plus root 15 and x minus 4 minus root 15. So it's 2 linear factors now. Okay, number 2. X squared minus 2kx, the coefficient is 2 minus 2k, so you have x squared minus 2kx plus half of the 2k, which is k squared, subtract the k squared, and then plus 1. Okay, the three terms can complete the square, so it's x minus k squared. Okay, what I can write at the back, okay, which way is better? Is that 1 minus k squared is better, or this is better? The top one or the bottom one, which one is better? What we want to do, like the question is what we're trying to do. We want to complete square, right? If we have the plus sign there, can I use any formula? A squared plus b squared is not equals to anything, okay? You cannot use any way to do it. So it's a squared minus b squared. You have a plus b times a minus b, okay? So we need the minus 1, okay? We need the minus 1, not the plus 1. Yeah? Oh, yes, yes. Should be here. Okay, so we need the bottom one. But there's a requirement for the bottom one. Because k squared minus 1 must be greater than 0. Okay? You must have that greater than 0. If that's not greater than 0, it's a minus thing minus a negative number, that's a plus. Okay, let's go back to a plus. So I cannot do anything to that then. So that is x minus k squared minus square root k squared minus 1. The whole thing squared. And I have x minus k plus square root k squared minus 1. And x minus k minus square root k squared minus 1. But the thing is k squared minus 1 must be greater than 0. If not greater than 0, I cannot put that under the square root and it's not going to work. So let's factorize quadratics. Okay, let's factorize quadratics. Okay, determine the rule for parabolas. Let's say that's too easy for you at the moment. So example 1, a parabola passing through 3 points. If it's passing 3 points, if there's no 2x-intercept, there's no turning point, then it will be using the general form. Okay, it will be using the general form. But the lucky thing is we have the 0, 5 here. We know the last c values. So what I will write is y equals to ax squared plus bx plus 5. And then I can substitute things in 1, 4 and negative 1, 10 into the equation. So I will have 4 equals to a plus b plus 5. And then I have 10 equals to a minus b plus 5. Okay, what I'm going to do is add both sides. So 14 equals to 2a plus 10. The b just cancelled. So 4 equals to 2a. A will be 2. So if a is 2, b equals to 4 minus a minus 5. That equals to 4 minus 2 minus 5. B equals to minus 3. So y equals to 2x squared minus 3x plus 5. Wait. 4, 2. 2 minus 5 is negative 3. Plus 3. Yep. Okay, that's the first one. The second one is you have the information of the turning point. Okay, turning point is a really good point. I like that point because if I know that point, it's giving me 2 pieces of information. Okay, if I know turning point is same as giving me 2 pieces of information, and I only need another extra point. Now another extra point is 3, 3. Okay, so what I can write is y equals to a. Okay, remember, always have this a. I use red for you. So you have the dilation. You only know the turning point, but you don't know the dilation. So you must have this a as unknown here first. And then I have x minus 2 squared plus 6. Okay, x minus 2 squared plus 6. And then pass through the point 3, 3. So sub 3, 3 in. So 3 equals to 3 minus 2 squared plus 6. That's 1, a plus 6 is 3, a equals to negative 3. So y equals to negative 3, x minus 2 squared plus 6. Okay, you must show how you work out the a values. Even though a is 1, you still need to show why a is 1. Okay, if you miss that dilation, you won't get, like, you lose half of the marks. Okay, lose half of the mark. Okay, example 3. Example 3 give you turning point at 0, 0. So that is a y equals to ax squared case. So you have 2 and 5. So 5 equals to a times 2 squared. So a equals to 5 on 4. Then y equals to 5 on 4 x squared. Okay, the next one, you have information at the 2 intercept. Okay, you have information at the 2 intercept. So y will equals to a. Okay, doesn't matter what kind of question you have. You always start from a for quadratic. Okay, it doesn't matter give you the turning point, intercept, or general points. You always start to write as a. So you have 2 intercepts. So you will use the x-intercept form. So it's x minus 0, x minus 3. Okay, you subtract the intercept. You subtract the actual intercept. And you have minus 1, 8. So 8 equals to 8 times 1 minus 0 and 1 minus 3. So 8 equals to minus 2 times 1 is minus 2 minus 2a. Wait, that's a minus 1. That's a minus 1. So I have minus 1. So minus 1 minus 4. So it's a 4. So a equals to 2. So y equals to 2x times x minus 3. So 2x and x minus 3. Okay, a parabola has x-intercept as 3 and and 4. You need to have information for 2 x-intercept, okay? If you know y-intercept, doesn't help. It must be 2 x-intercept. So you write y equals to a bracket x minus -3 and x minus 4. So y equals to ax plus 3 and x minus 4. You don't know the a value, but have another point 124. So 24 equals to a 1 plus 3 and 1 minus 4. That is 4 times -3 is -12a. So a equals to -2. So y equals to -2 x plus 3 and x minus 4. Okay, that's how we find equations. They are year 10 level question. Okay, shouldn't have any problem with that. So next page, language of polynomials. So we learned polynomials last year, and we know polynomials a to the power of x to the power of n plus a1 x to the power of n minus 1. So in a decreasing order for the numbers. So first of all, to make this become a polynomial, we need to have non-negative, and we need to have whole number, and that needs to be powers. Okay, 3 requirements here. First one, it must be non-negative. Second one, it must be a whole number. The third one, it must be the power. Okay, the number must be a power. So let's have a look at the first one. This one is not a polynomial because 1 on x is x to the power of -1. It failed the condition number 1. Okay, this one we have 2 x to the power of 2 to the power of 1 to the power of 1/2. It's not a whole number. It failed number 2. 3 to the power of 2x. Okay, fail number 3, the number is not a power. Okay, x is the power, 2x is the power, then that becomes exponential. This is called exponential. Okay, so students always confused with those two. Okay, that's an exponential. And that is a polynomial. So base with x and the number on the power, so that's a polynomial. If the base is constant and you have power of x terms, that becomes exponential. Okay, so that's polynomial, that's exponential. In general, a polynomial can be written in that form. I don't care what's that form, it's just a really long expression. But we have all the a values are the coefficients, and we have a single thing. If px equals to 0, we call that 0 polynomial, and it's useless. Why we want to know px equals to 0? Okay, so but like it's just a name. Okay, there's a name. It called px equals to 0. Okay, just a 0. Okay, that's a 0 polynomials. And what is the leading term? Leading term is the term with highest power. Okay, leading term is important. Leading term is the term with highest power, which is a n x to the power of n. Then the degree of polynomials is the index n of the leading term. So what's the highest power? So that's the degree. Okay, and we have monic polynomial. So monic polynomial is leading term of coefficient 1. So for example, I have x to the power of 4 plus 3x to the power of 2 plus 1. That will be a monic coefficient, monic polynomial, because the leading term got coefficient of 1. Okay, that's a monic polynomial. So this will not be a monic polynomial because we have leading term with coefficient 2. Constant term is the constant. Okay, it's really, like, I don't want to talk about that. Like constant is the last number at the back. Okay, polynomials with 2 terms are called binomials. Okay, called binomials. If with 3 terms are called trinomials. Okay, so we have this one is a quadratic. Okay, 3x squared plus 2x minus 1 is a quadratic. But this is a quadratic trinomial because we get 3 terms. Okay, it's a quadratic. So what kind of graph is that? It depends on the leading term. The leading term got power of 2, so that's a quadratic. So it's a quadratic with 3 terms, trinomial. The next one, 3x squared minus y, is called a quadratic binomial. That's a quadratic, but only with 2 terms. It's quadratic binomial. And what's that? So what's that? 3x cubed plus 1. Yep, it's a cubic binomial. Okay, what's the leading term? The leading term is 3, power of 3, so it's a cubic. Okay, this is a cubic graph. How many terms we have? We have 2 terms, so it's a cubic binomial. So there are all some names, and I think they are quite useless except the leading term one. Okay, I must tell you the truth. But it's good, like if you know that, and it might be a one multiple choice, like 0.1% of the chance to have a multiple choice ask you what's px equals to 0 chord, and you should know that's a 0 polynomials. Very unlikely, but I just go through that with you. And the next one is this table. Okay, I don't want to go through this table anymore. It's so like get enough of that table. But like we know that table: constant, linear, quadratic, cubic, and quartics. The last one is power 5. We will say that's the polynomial of degree 5. Okay, we don't have special names for anything greater than power 4. So it's like polynomial of degree 5, polynomial of degree 6, polynomial of degree 7, and so on. Okay, so we don't have special names anymore. We keep at the quartic. And we know the degree must be 0, 1, 2, 3, 4, 5. Okay, that's the degree. And the coefficient for x, I think you know what's the coefficient for x. That's 0. Okay, the first one is a 0 because we have no x term, it's 0x. And then the second one, just look at what's in front of x and should include the sign as well. So negative a, that's a 0 again. You have 1 for that because you have 1x, and that's a minus 3. So you know how to do that. And the constant will be that's the constant. That's the constant, and there's no constant here. That's the constant, no constant here, and no constant here. Which one? Okay. And next thing is example 1. Okay, example 1, want to find px equals to that and evaluate p0 and p1. Okay, evaluate p0, p1. I think last time, the first time we did, you are substitute a values into the wrong place. Okay, make sure you substitute things into the place of x. Okay, not substituting any other numbers. So x is the variable, so x can change, a cannot change. A is already a fixed number. Okay, so if I ask you to substitute things in, you will substitute in those boxes. If you really consider, I would recommend this method. Okay, draw the box out and put numbers in. So you evaluate P0. So basically means you put 0 in all of that, and that gives you A. Okay, that gives you A. And P1, put 1 in all of that box. So it's 1 minus 2 plus A. That gives you A minus 2. And then you want to know what is P2. P2 equals to 3. So you need to know what is P2 first. P2 is 2 to the power 4, gives you 16. Minus 2 to the power of 3 gives you 8. Minus 2 times 2 to the power of 2. 4 times 2 gives you 8 again. So that's another 8. And plus A. And that equals to A. Not surprised. And that equals to 3. So also P2 equals to 3. So A equals to 3. Okay, A equals to 3. Okay, next one. This one I don't really like to explain this one, but I will just roughly go through that. you have sum of, we have learned that. Okay, we learned sum of functions, we learned subtract of functions, and we learned the times and divide for functions. One thing is, what's the domain that should be? What's the domain? So you have fx and gx. What's the domain for the sum? Intersection, okay? It's intersection. The domain is intersection for all of these functions. So your f gives you -4 to 3. I still like to do this way. -4, -2, and 3, and 5. Okay, that's the endpoints for both. So for this one, you have -4 to 3, open circle and close circle. You have the here to here. Next one, you have -2 is close circle, and to 5. 5 is open circle, like that. The overlap region is from here to here. Okay, those two parts are the intersection part. So the domain for f plus g will be -2 to 3. And it will be the same to f times g. And it will be the same as f minus g. Okay, the domain are all -2 to 3. Okay, the domains are all -2 to 3. All right. Okay, I'll give you two suggestions. When you write domain and range, try to put that into the function set notation. Do not write x smaller than 3. Okay, you learn like better things now. You will write -infinity to 3. Okay, so that's the first suggestion. And the second one, I every time ask you to find roots for some function. If that's not starting with y, say start with f, g, h, like things like that, you write the function notations. Okay, you write function notations. Because if it's a function, then it depends on the root and also the domain. So the function notation will give you both things. Okay, root and domain. If you just write y equals to something, it's a little bit like missing half of the part. Okay, missing half of that. So write range and domain into the set notation. Second, write all the roots into function notation if you can. Yeah. They're both acceptable and both are really good ones. Like I will say they are all good. I will like the 0 to infinity one because you don't need to think a lot. But like r plus union 0 is also means the same set, so all the same. Another thing is from your test today, I see a lot of answers like 0 to -infinity. What's that? And 4 to -infinity and things like that. Make sure you -infinity on the left hand side. Okay, -infinity on the left hand side, positive infinity on the right hand side. Do not make mistake like that. You will lose mark. Okay, I'm not kidding. You will lose mark because of that. Because it's a wrong notation. Okay, wrong notation. I think at least 3 or 4 of you doing the same thing here. Because I go through the paper, I say, oh, so many people go through in that way. Okay, next one. For the next thing, we have, okay, what this really means. The degree, okay, the degree of f plus g, if you plus two functions together, the degree will be smaller or equals to the maximum degree either in f or g. Okay, so what that means, if you have degree of f equals to 4 and degree of g equals to 2. So the degree of f plus g will be smaller or equals to 4. Okay, so when you add up two equations, the degree is not summed together. It actually can reduce. Okay, the maximum thing you can take is the maximum degree for either of the functions, but it can be lower. Like it can be lower than the actual degree. What happened? Like why? Why the degree will be lower? Like why will be smaller degrees? Say we have fx equals to x cubed, x to the power 4 plus x to the power 3 minus x plus 1. And gx have the same thing. We have x to the power minus x to the power 4 plus x to the power 3 minus x and plus 1. There are two different functions, but when you add them, the x to the power 4 disappeared. Okay, when you add them, the x to the power 4 disappeared, and the highest power becomes 3. So the highest degree actually for f plus g becomes 3, not 4. So it reduced. Okay, reduced. But when you do times, that will be easy, because when you do degree f times g, that will be the degree of f plus the degree of g. Why? Because when you times two things together, you add the power. You add the power. So f got degree 4 and g got degree 3. When you times them, the power actually summed and it becomes 7. Okay? So when you times the degree together, okay, the highest term will become x to the power 7. Right? The highest term will become x to the power 7, because you times them, it's not going to reduce. Even though it's a minus number in the front, like say minus x to the power 3. When you times them, that still give you power of 7. So the maximum is equals to fg plus f degree g of degree and f. Okay, sum them. If it's time to sum the degree, if you add them, that will be smaller or equals to the maximum of one of your, the maximum degree from f or g. Oh my god.
Start with this announcement. All students of 9G return to the gymnasium now. Thank you.
Okay. Scared and can't teach anymore. Okay, so we're almost there. Okay, find the values of a, b, and c for which two equations. Okay, those two are equal. Okay, we can see that's a polynomial. Let's say we have a polynomial number 1. Say that's fx. And the right hand side we have gx. I want to find some values to make fx equals to gx. If two polynomials wants to be equal, all the coefficient of the particular term must be the same. So the coefficient for the x term must be the same. The coefficient for x squared term must be the same. So everything must be the same. So the coefficient 9 must be equals to c. A minus 5 must be equals to, okay, what's the x term? There's no x term, so that is 0. There's plus 0x squared plus 0x plus 0. Okay, they're all zeros. So a minus 5 must be 0. 2b minus a must be 0. Then minus 13 over 2 plus minus b plus c must be 0 again. So from here I know c equals to 9. From here I know a equals to 5. From here I know b equals to 5 on 2. And from here I won't know really anything because I already worked out ABC. So this step is for checking. Okay, it's for checking, not users. I need to check. If that one cannot hold, we cannot say we have solutions. Okay, do you understand? Like even though we work out ABC at the beginning, but if we put in the last equation, it's not working, which means I don't have any solution for ABC. Okay, it's not going to work. So left hand side of this equation will equals to minus 13 over 2 minus 5 on 2 and plus 9. That equals to minus 18 over 2 plus 9, and that is a 0. So right hand side equals to 0. So left hand side equals to right hand side. So I can say A equals to 5, B equals to 5 over 2, and C equals to 9. The last step, you must check that, otherwise you lose marks. you need to substitute things in to see whether the last equation hold or not. If it's not holding, I can't have my constant to be 0, which means I cannot make those two polynomials to be the same. And then we don't have solutions for A, B, C. Okay, that's the logic. Okay, that's the logic. All right. For this thing in the box, I don't really need you to know to the power 4. That's too much for you to remember. But all the rest you need to know. Okay, all the rest you need to memorize. Okay, expanding something to the power of 3, a cubed. Okay, the most important one, and you will forget, is this one. Can't use red. The last one. Okay, we need that to factorize, and you always forget that. Okay, I know. So that is the most important thing from this box. I think you know how to do perfect squares, you know the dots. You can expand a plus b to the power of 3, but the last one you really need to know. And example 4 is too simple. Okay, I'm just skip that. Okay, just skip example 4. You know how to expand. Okay, you know how to expand. One thing. Can you go to page 4 for page 7 for me, please, and see example 4. I want you to think about this method at home during the weekend. So have a think about that, and it will be easy for you to do next lesson thing. Okay, so we have a polynomial px, and that equals to that. And I want to divide that by x plus 2. I want to divide that by x plus 2. So most of you will say try long divisions, right? How many of you will not use long division for this question? 1, 2, 2. Okay, so you need to learn another method. Okay, you need to learn another method if you really want to use long division. I will not recommend long division because it's so easy to make mistakes. So this method will be list the things in the order, in the decreasing order. So x cubed, x squared, x and constant. If you don't have x term, you use a 0 to put there. So I will write the coefficient of all these terms. So 1, 1, minus 14, minus 24. Okay, that's all the coefficient we have. 1, 1, negative 14, and 24 for the px polynomial. And what I'm trying to divide, first, it needs to satisfy two things, what we're trying to divide. First, what we're trying to divide is a linear. If it's a quadratic, it's not going to work. Okay, what I'm going to divide is a linear. Second, it's a monic polynomial. Okay, what's monic? What's monic? We just learned. Not in front of x, it's in front of the leading term. And x is the leading term here, so the coefficient is 1 in the leading term. So it's a monic one. Okay, it's a monic linear. It needs to be linear and a monic linear. Okay, so now it satisfies that. It's x plus 2. So I will make x plus 2 to be 0. Then x will equals to negative 2. So negative 2 is the number I'm going to submit here. Okay, I'll put here. Okay, for this table, how we can complete this table. So the first number, whatever the first number is, I always directly write the first number down. Okay, directly write the first number down. Okay, for the second one, that equals to negative 2 times this one, and plus this one here. Okay, the negative 2 times the red one and go to plus the green one. So that gives you a negative 1. That gives you a negative 1. Okay, for the next box below here, I will use the negative 2 to times the -1, the black place, and go to plus the -14. Okay, whatever on the top, I'll go to plus that. That is -12. Okay, 2 plus -14 is -12. And the last box will be -2 times -12 and go to plus the -24. That is 24 minus 24 gives you a 0. So I have a big 0 here. Okay, so what all of that represents? What all of that represent? So let's write down, that's the x cubed term, that's the x squared term, that's the x term, that's the constant term. Okay, for the things below, okay, the bottom row, that's the coefficient for x squared term, that's the coefficient for the x term, that's coefficient for the constant, and the last box is remainder. I have a remainder here. Okay, the last one means the remainder. So I have remainder here. It's remainder 0. So x plus 2 is a factor of this px. So what I can write for px? Px equals to x plus 2. That's what you're trying to divide. And now I have x squared minus x and minus 12. That's the coefficient of what you have left. Okay, -1 minus 12, 1 minus 1 minus 12. And you have remainder 0, so you plus a 0 at the back, so no remainders. So you totally avoid long division, and I think it will be much quicker. Yeah. Synthetic or something. I think it's in your textbook, but most teachers will still only show the long divisions. Because long division will be helpful if you're trying to divide things other than linear. No, too long. Inspection, yes. For cubic is working, but for quartic it's not going to work very well then. If you have a quartic and then you have a linear, and then you're left with a cubic, you can only know the first and last term, and then have two middle term, which is the x cubed term and x squared term. Then it's really hard for you to work out those numbers in between. So I would recommend this one if it's a quartic. But for this question, the problem for this question is the inspection method can only work if you know that's a factor already and you work on that, right? But you don't know x plus 2 is a factor yet. You don't know that's a factor yet, so you can't really, if it's not, you have another constant at the back and it's not going to work for inspection. So that method will be applied for every single thing. So that's I think it's the best. Okay?
So inspection, you get a remainder.
If you feel that's quicker, you can do that, but I feel like it's a little bit slow for me to do that way. But it's also if you can work the same thing, that's the same.
If you then try working out
yeah, it can lose mark if you it's a 3-mark question. You may lose some mark. You just look at it. Yeah. Okay. Any questions about this method? I'll do a last one. Okay, I'll do last example. Let's do page 9, please. Page 9. Page 9, example 7. Last example. Okay, last one. Okay. I want to factorize that. Okay, I want to factorize this one. That's a cubic. That's a cubic. I want to factorize that. But I don't know any factor yet. Okay, I don't have any idea about any factor we have here. So we need to try some numbers. Okay, we need to try some numbers which could be a factor. So you know that if px equals to that, if you can find the number a, pa equals to 0, then x minus a will be a factor. Okay, that will be a factor. Okay, now I want to show you the synthetic way why it's good. Okay, you don't want to substitute numbers in and then you cube it plus 2 times to square it and then you do that. If that number doesn't work, you need to try another one. It takes time. Okay, it takes time. It works, but takes time. So, and again, what number worth you to try? You are not going to try 11 for this question, okay? So what numbers are worth you to try? Is the coefficient for the last number, the last constant. So what's the coefficient? Plus minus 1, plus minus 2, plus minus 3, and plus minus 6. That's the number worth you to try. They're all the factors for the constant. And also, if you have a number other than 1 for the leading term, you also factorize this. For example, the bottom one. The bottom one, you have plus minus 1, plus minus 2, plus minus 1, plus minus 3. So plus minus 1, plus minus 2, plus minus 3 worth you to try. It's the leading term and the constant term. Find the factor for the coefficient, and those number are the number you're aiming for, okay, you're looking for. You're not going to try 4 for that question. It's not going to work. Okay, you know that must be one of the number between here. Okay, next thing is, you don't want to substitute single numbers in, because even though you work out x minus 1 is a factor, so what do you do next step? Long division, right? You still need to do long division. So why not start with the static method directly? So we will have 1, -2, -5, and 6 as factors. Okay, that's the factor. Coefficient 1, -2, -5, and 6 is the factor for the px. I will try a number. 1 is always the good one to try. You start from the smaller number to the larger numbers. I'll try 1. If I try 1, the first one always coming down. Okay, the first one always come down. Okay, use those two times together. 1 times 1 to go to plus the thing on the top, which is -2 is -1. Okay, give you -1. Okay, 1 times -1, go to plus the number at the top, which is -6. The last one is 1 times -6, go to plus 6, which you have a 0. And that is the remainder place, and I'm looking for a 0. Okay, I need a 0. I need a 0 here. So, which means x equals to 1 is a good thing. Okay, that's a good number. 1 make the equation to be 0. Then I will have factor x minus 1. Okay, 1 to make the whole equation to be 0, then I need x minus 1 to be the factor. Because if PA is make that PX equals to 0, then x minus A is the factor. So then the good thing is, those things are the coefficient for what has been left. You left with a quadratic. It's a x squared minus x and minus 6. You directly work out what has been left here. Okay, the rest of them. And then you have x minus 1, x minus 3, and x plus 2. Here I have x minus 3 and x plus 2. And it's really quick. Okay, I totally avoid long division. Okay. For end of year exam, it's all about how quick you can complete the paper. So do not waste time on useless things. Okay, do not try to learn like fancy method and try to show things. What method can give you numbers directly? Use that method. Okay, I will stop here and I'll keep going next lesson. That's the most important thing I really want to show you. So the synthetic method. Okay.